All right, looks like we have most everyone here, and it is 1 p.m., so we'll go ahead and get started with today's online demo for Lantek Expert Cut software. For those of you just joining us, again, my name is Kevin Must, and I'm the Marketing and Operations Assistant for Lantek USA. All right, so before our demo, I would like to introduce Lantek for those of you who may be unfamiliar. Here at Lantek, we have over 30 years of experience in CAD/CAM development and support, with 20 years of experience in MES and ERP development, support, and integration for metal fabricators. Over the past 4 years, we've been developing advanced analytical tools with a focus on utilizing the IIoT, or the Industrial Internet of Things, in the past 2. So with 20 offices in 14 countries, Lantek currently supports over 20,000 customers in 18 languages while maintaining over 100 OEM agreements. So this extensive industry experience has allowed Lantek to understand the pains of manufacturers, and 5 of the pains that we hear most often come down to scrap or wasted material, non-value time or rework, inaccurate quoting, minimal work and process insights, and lack of visibility and capacity for scheduling. Our studies have proven that our solutions have helped customers improve every day. On average, we help manufacturers increase material utilization by 8% and productivity by 25%. We have achieved 99% quoting accuracy with a 30% reduction in inventory. So all of these paired together helps to provide over 40% more on-time deliveries to your end customers. Providing these solutions and integrations for all aspects of your shop floor creates what we call an interoperable transparency. So from order to shipping and quoting and everything in between, you can see what's going on from each department. All right, so that wraps up the introduction of Lantek and leads us into our Lantek Expert Cut demo. So again, we know your pains when it comes to creating jobs, maybe a little bit inefficient. Also, bringing in geometry files, you may find that some programs don't have the full support for some geometry files. And it can also be time consuming to create efficient nests. So how Lantek helps you improve on this is with all of our different integrations and industry experience, we are able to create jobs easy and quickly. And we can also import parts from various formats, regardless of if it's DXF, DWG, PDF, or any other major file format that's out there. So all this paired together really gives you a quick and efficient nest creation. To speak more on this, I would like to introduce today's presenter, application engineer for Lantek USA, Brandon Beecham. Brandon brings us 25 years of manufacturing experience, with 10 years managing operators and the last 3 supporting Lantek users. Thanks for joining us today, Brandon. I'm going to go ahead and pass our demo off to you.
Okay, everybody. This was Lantek. We're going to start and just jump right into it. When you open up Lantek, this is very important. This is your job managing screen here. This is where you're going to create your jobs, your folders. I see customers do this by date, month, customers that they have, so on and so forth. But this is very important because this needs to be non-confusing for everybody involved. So it's pretty easy. We'll just, if it was going to make this a date, we'll say this is October, week 1, and we'll create jobs inside the folder. And it's easy to structure just like that. Now, we can bring in DXFs, DWGs, MECs, MEC is Lantek's extension, and PDF as well. So we'll just go to DXF. Here we are. We give it its reference number. You can give it the part name. You can give it its quantity. tie it to, if you have just one machine, you're going to go ahead and just select that. If you have several machines, we can do that as well. And you just select the machine that it's for. Select the material it's going to be. And hit OK. And here your part is. Now, at this point, one thing about Lantek, it is very user-friendly. You can adjust everything on the fly. As programmers, we see this stuff happening every day. I brought this in, and I've got it tied to 0.125 thickness. Well, I will change that. Just that simple. Now at this screen, when you're bringing it in, here you have the same thing. You've got the CO2 laser I'm tying it to, the material I'm tying it to, the thickness. You can put user data in here if you want to. Your rotations, say if we're doing some grain line stainless, or if we're using some parts that have broke in the bending process because of the grain in the mild steel or cold roll steel, you can tie rotations to this as well. So once you get the part the way it is, you can open up the part. Here, this is very important as well. A lot of customers have DXFs coming from all over the place. You might get it from your customer, you might be getting it from designers, so on and so forth. So we're going to verify the part just to make sure the geometry is good. Okay. Sorry guys, I didn't realize you guys couldn't see that screen. So here I am, I've opened it up, I'm in drawing level, and I'm going to verify. Now, number of parts, 1. Number of closed contours, 5. 1, 2, 3, 4, and then the outer geometry, that's 5. Open contours, it doesn't find any, and small elements, it's not finding any there as well. Small elements that are elements that could be smaller than beam width, which your machine really couldn't cut. Now, what would happen if there was an open contour? So let me go ahead and do that real quick. Now we can see that with our eye there, that's a open contour, but most times you can't see that. So that's why the verification is very important. And here it's telling me there's no part. That should tell me right off the bat that there's an issue. We can see the number of contours have changed, and open contour is 1. So we put points in open contours. Now I found it. I can zoom up on the view. There it is. And we'll just fix it. Now, once we're done with fixing it, we'll verify it again. F8 makes you go full screen. And now there's no open contours. And when we go let it finish, it gets rid of the points for us. So now that we know that we got a good part and the geometry is good, everything's good, we're going to save it and go to nesting. Now nesting, there are several options here. We can do all, active sub job, one sheet, so on and so forth. Those are your ways of automatic nesting. Now here we are, we notice I don't have a sheet. This is mild steel 0.075, and I don't have no material. Again, here I am at nesting level, and I'm able to work on the fly. And I just created my inventory that easy. Now I have my sheet. Manual nesting, we'll just click on the part. and we'll move it around. Here you can come up here and you can use these rotations, or if you notice the control 9, you can place it where you want on the sheet where it's going to sit, and you can check your rotation out there. Again, I'm changing on the fly. I've only got one piece there. And I've just changed it. So now, one sheet will do just as it says. It does one sheet at a time. There it is. I like what I got there. I'm going to accept it. Then we'll go to machining, automatic. There it is. We have it machined. At this point, you can run a simulation. You can check and see how it's working and things, see if you like what's going on. And if you're happy with it at this point, we can just click save. Now, here's my machine code. This is what's going to go to the machine. That's what's going to run this nest. And this is the report for your operator. The report is giving the material type, how many times does the operator need to run this sheet to get the quantity, the job number, the size of the sheet and thickness here as well, and the CMC number he has to find to be able to get the part. Also, for your operator for doing the first article inspection, you notice this right here, all the parts have a number 1. So if we look down here, number 1 is DXF PLR 101, and your operator can grab that print, check his part to the print, make sure that everything is good and correct. Also, it tells you a total of 101 pieces, and we got 55 on the sheet, and we still have 45 more to run. And that's start to finish the basics. And we're going to dig in a little deeper. And I'm going to create a new job. Now, you do not have to bring in your parts, and you do not have to separate them by machine, by material type, thickness. You don't have to separate that stuff like that. You can do it all from here. I'm going to bring in a DXF. Some of you guys have seen this in the past where you guys have the multiple part DXFs. Well, there's a really cool feature here inside of Lantek where you can bring in those multiple part DXFs and it will find it part by part and separate it for you automatically. And the configuration for this is here, save by parts. And I hit open. Now I'm going to tie a machine. I'm going to tie a material. And I'm going to tie a thickness. And hit OK. Now this will take just a minute. There are 145 parts, I do believe, on this DXF. And it is right now, as we're speaking, it is finding every part, separating every one of them, giving them its own reference name, so on and so forth. Now, once this is done, you give me about 10-15 minutes, and at the end of this, I'll create enough work for a laser for about 2 days solid with what it's doing right now. Like I said, there's 145 parts, maybe a few more, that are in this DXF. And it is finding every one of those part by part, giving them its own reference name, bringing everything in, separating it for you. In the old days when you dealt with this, you had to bring in the DXF, you had to bring in the part, you had to delete everything else around it, bring it again, and we would have had to have done that for 140 to 45 times. So as you can see, it came down, there's 145 parts, and it used a reference. Sorry, that's what it was. That's what I named it, Beecham sample. And it started at 1, 2, and it just core aligned all the way through. Now, one thing I want to do here real quick, as I was showing you before, we can work on the fly. Well, I'm going to change some thicknesses and material types on this stuff that we brought in, just to show you how the automatic nesting completely works. So these here, we're going to make aluminum. Gauge. And then, as you can see, I'm working on the fly. I'm using shift, and I'm selecting a group of them at a time. Okay, so now I've got 3 or 4 different thicknesses, and I do believe we're ready to try this out. So we'll go to nesting. And here we are. This is your sub jobs over here in the nesting screen. This is your nesting explorer. Now that we have aluminum 048, mild steel 0.075, mild steel 0.25, stainless steel 0.375. And at this time, once you have Lantek completely set up and is ready to go for you, it is really just this easy. We'll hit do all. Here it is, going through and finding every nest for every thickness, for every material type. Okay. Now, this one right here didn't go, so that tells me that there's no material. So let me add that real quick. I did things like this to show you guys just how easy it is to change things and work on the fly. So one thing that's kind of important to us as programmers is being able to work on the fly. Now, once I'm done, you see I've got all the sub jobs are done except for the one. So I want to work just with one certain sub job. So I'm going to highlight that sub job, and I'll use active sub job. And there it is. Now let's look at the nests. They are all machined and ready to go. So we'll start at the top, and we're saving. Grab them by sub job and start the saving process. It'll save them all for you. Creating its own CNCs for you that you can find, and we can set that up in the machine configuration side of this, where you start with some controllers are different. Some use 4, 5, 6 digit numbers. We set that up in the machine configuration and have it set for you. And there we have it. I can click this one, this one. There's a CNC. So we'll look at this nest. That's the CNC created for it. And so there you have it. In about 10, 15 minutes of honest work with no talking, I've just created enough work for a laser for about a day, maybe two. So here I am, I'm back at the job screen. And that was the job. And again, here now is all the nests here for you as well. We go back to nesting. We're going to use this one right here. Remnants. If you guys like to track your remnants and want us to track your remnants for you and help you with your remnants for the efficiency and reduce the scrap and waste, we can do that here. And there we have it. I have this. Let's give it this name, 18 gauge 6061-2. And I'll save this. Now, when I come in here, there it is, 18 gauge 6061-2. There's the one remnant with its size, okay? And it tells you here that it's a remnant, so that you can find it in your library and use it later. Also, we can set this up automatically to when you click save and there could be a space for a remnant, it will create the remnant. Also, in most situations we see, most guys will grab a forklift, go to the rack, grab their 18 gauge stainless steel that they're going to use for, and they'll pull that right in and they start pulling sheets off of that. When you do that, your remnants are laying on top most generally. So we can tell the software when it's doing automatic nesting to use remnants before full sheets, and it will do just that for you as well, helping the operator along the way. So that's job creation, remnants, saved by part. We just brought in a multi-part DXF and we saved it. And like I said, we've created about 2 days worth of work for a laser here in about a half an hour's time. Also, the DXFs, once the parts are brought in, you have a database. Lantek has a SQL-based database, and your parts will always be in that database. If you need to run those parts again, you don't have to bring those in again. You can just grab them from the database. Your configurations for your machines are for here. This is your machine configuration. This is your system and the machine configuration. Usually everybody asks me about this point is where is Lantek getting the information to create lead-ins and lead-outs, cutting conditions, so on and so forth. Well, all this stuff is done from here and the material thickness dependent data. This is where you can set it up. We as programmers, we all automatically know when you're using mild steel or cold rolled steel, 18 gauge, 16 gauge, you can let it put whatever type of lead in and lead out it's going to use. It's going to work. Everything's great. But once we get into the 1/2 inch, 3/4 inch, 1 inch materials, you start learning that, okay, this arced lead in works so much better for my contours, to be cut more clean. And you can set this stuff up here. Like if let's go straight into the 1/2 inch mild steel. It was going to be in this one here, automatic lead in and lead out values. And here we are. These are the lead ins it's going to use. Here I'm telling it where I want it placed around the parts. This is where I want it placed around the holes. This is the configuration for inner contours, inner circular contours, outer circular contours, inner square or rectangle contours, outer squares, and oblongs. And the last 3 are special. So once you click on the inside holes, you hit modify, and here's your configuration. Here's the type of lead in you want to use. You've got all these types. You've got the lead in size, lead out value, an S value if you want to do an overcut to get rid of the divot by the lead in, lead out, so on and so forth. That's how you're going to pull the information from there. Contours. This is how the system knows what cut contour is going to use. You're saying anything from this size to this size. I'm using cut quality, this cut quality. I'm going to do it on all contours, but you also can say inside, outside. I mean, you've got a lot of options in here for that stuff. So once you get all this set up, and especially the material thickness dependent data with your lead ins, your cutting parameters, your automatic technologies, your sheet parameters. Let's talk about the sheet parameters. You want to leave borders around it. You want to put borders around your sheets. Here you can set this up by material type and thickness. Head raising test. How do you want the head raising test to work? If you want to do the head raising test by material and thickness, so on and so forth. Most people I see doing that all the time. If you're going to want the head to come up, and they're going to do it that way all the time. But we all know this is manufacturing, and everybody is a little bit different. So if you need to use it, you can. Machining order. You can do it by start point direction, size, so on and so forth. We also have minimal heat. Now, if you have, we're doing some really thin 0.048 18 gauge stainless steel. We got to worry about heat. You can do that here by minimal heat. Also, let's go back to nesting. This is just, it's a lot of stuff for the programmers would like to see here in nesting. Here I am. I got this. Okay, this is 14 gauge, but we're going to say that this is like some 1/2 inch material or so on and so forth. You can destroy the sheet framework automatic and destroy the sheet framework manual. Manual, it is just like it says. You click where it's going to go. Offsets and parts, 0.025. Edge of the sheet, 0.025. Start in the middle. I like to start in the middle in all the cuts because I don't want no pierces, divots into my parts or anything like that. So I start in the middle with all, and I hit OK. And if you look, I'll zoom up here. There it's cutting there. It's cutting there in between the parts. And down through here. Now, we can set this up to do it automatically as well. Common sheet framework automatic. And you tie in information here. And hit OK. And you can see it has cut the sheet completely up. 1, 2, 3, 4 cuts across it. And 1 the other direction, vertical. So there you have that. Also, you can destroy sheet holes. And that's doing just like it says. If we had some parts here that had some square cutouts and your square cutout is popping up and it could hit the head, you don't want to add a micro joint because it's hard to get a mini grinder or a file in there. You can destroy the sheet hole and it will cut the hole up into little squares given the dimensions you give it here and let them fall in between the grids. Also, a lot of people ask about this. Now that I have this set up, I'm going to use this part. Nesting for common cut now, as you can see, and now we'll machine it, automatic. Now, you can see the outside is still red, the inside holes are still red, but you can see this blue right here. That means that's where it's common cutting. That's just one line, one width. Okay, then here we are. We'll create a remnant, save it. Now we've got this. Again, this is Lantek in a nutshell. This is pretty basic. This is, I've showed you bringing in parts. We've talked about your different parts, your extension types, DXF, DWG, PDF. We've seen how to bring in multiple part DXFs, single part DXFs, so on and so forth. We went over the verification of a part. Also inside this verification of a part, you have a full drawing package. Pretty simple. It's just like any other package. It's just everything's labeled a little different. You've got your one-touch figures. You can move geometry, so on and so forth. You got your verify part. All of it's here. You can break elements, fillets, chamfers, so on and so forth. And also inside nesting, we went over your Nesting Explorer. We went over your material library. We went over your nesting. That's a good one to see. Okay, my part is bigger than my sheet. So I'm going to take and change my sheet size real quick. Again, fixing it on the fly. There it is. I have my part. Machining tab. And we went over the manual nesting. Now this is something you're gonna want to be happy with here, I would say, because it gives you full control. Yes, this is Lantek. It's going to do everything automatically for you, and it's going to give you one of the best efficient nests you're going to see. But we as programmers all know that you're going to be able to look at a nest and think, I can do that better. And you may be able to, because we give you the tools here to do so. Also, if you're doing a serious nest, I got that part placed there. I can do copy that. We can do advanced copies, so on and so forth. That's about it. Lantek in a nutshell. This is just, your basic usage of Lantek. I think we're going to do another one of these at another time. That's going to be more advanced options inside Lantek. Will be much deeper. So at this point, I think I will hand this back over to Kevin.
All right, awesome. Thank you for the great demo there, Brandon. It's greatly appreciated. I'm going to go ahead and take control back on my screen, and we did have a few questions come in throughout the demo. Our first one that we received is wondering, how do you know material usage and max consumption while at the nesting level?
As I showed you in the nesting level where we are creating sheets, you notice when I created 250, and it will start counting backwards from 250. Once you get to 0, if you notice when I was auto nesting and didn't have material, how it actually just wouldn't do anything with any of the parts or anything, it just sat there and it left that sub job empty. It will do the same thing. It's going to let you know, hey, I need more material before I can run these parts.
Okay, great. Another question that we had, can you process by sheet only versus do all, or is there a differentiator between that?
It's just like your basic, I'm going to get it done fast. Your one sheet gives you a little more control, like I was telling you. We are programmers, and let's face it, Lantek does very well. Has a very nice nesting algorithm, and I have put it to the test over the years, and it will do very well. But as a programmer, you're going to be able to look at nests and say, okay, I can do this different. Well, if I'm going to go through a sub job and I'm going to do one sheet at a time, that way I can look at that sheet, examine it, see if I want to change anything, and then move on to the next.
All right, perfect. Looks like I have 2 more questions here. One of them, is this connected to a business system to better manage your parts coming in, parts going out, sheets, all that stuff?
Actually, it can be. We have other software packages, Manager, WAS, so on and so forth. We have other ways of handling that, yes.
Okay, great. And looks like the last question that's come in so far. So how can you, or is it possible to auto nest for multiple thicknesses of sheet parts?
Yeah, I think I showed that in the dual. I created 5 different thicknesses, and it went through all 5 of those for you. And when you differentiate that, you can do active sub job, and that's going to do one sub job at a time. And your sub jobs are going to be labeled by material type and thickness. 16 gauge stainless steel and 1/8 inch aluminum, 1/2 inch mild steel, so on and so forth. It will separate them that way. You can do active sub job or do all. But when you go to nesting and you bring in, basically when you come in, you grab your travelers. You're not going to just separate your travelers anymore. Oh, this is my 7 gauge. This is my 16 gauge. This is my stainless steel. This is my mild steel. You're just going to bring in those parts all at once and let Lantek separate every bit of it for you.
Okay, and just had one last one come in. We have someone that is interested in if we send, or if they send parts to us, are we able to do a nest study for them?
I would be more than happy to do a nest study. More than happy.
All right, great. So that wraps up our demo for today. If you would like to send us any parts to do a nest study or a time study for you, feel free to send them to info.usa@lantecsms.com, or you can send them directly to myself, k.must@lantecsms.com, or to our technician, Brandon Beecham, at b.beecham, that is BEECHAM, at lantecsms.com. If you have any further questions that may be more specific to how your business operates, feel free to give us a call at 877-805-1028. I want to thank everybody for joining us today, and keep your eyes peeled for a recording of this either tomorrow or Monday. And as Brandon said, we will likely be doing a further demo that gets a little further into how we tie into our business systems later on down the road. So if you have any questions, feel free to shout. If not, enjoy the rest of your afternoon, and thanks for joining us today.